Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, question 7 on the 2014 paper 1 was also a financial maths type question. So Mary bought a car for 20,000 on the 1st of July 2010. The value of the car depreciated at a compound rate of 15% each year. Find the value of the car correct to the nearest euro on the 1st of July 2014. So 1st July 2010, 11, 12, 13, 14. So that's 4 years. Okay, so the relevant page in your log tables is page 30. And we went through some of this in the other videos as well. The first one there is a compound interest one. P is the principal amount, and you'll see the same thing in depreciation formula. So these formulas are the exact same, except one is a plus and one is a minus. One is earning interest, that's compound interest, and depreciation, one is losing value. But out from that, the formula is the same thing. Okay, the words are slightly different. P is the initial value, P is the principal. Okay, principal is a financial term for the amount you invest. Initial value is the starting value of a device. Okay, F is the final value or the later value, whichever you want to call it. T is the time in years. Where am I getting that? In all of the following, T is the time in years. Okay, and then this I that appears in the brackets of them all, I is the annual rate of interest, depreciation or growth, expressed as a decimal. So that's really important. 8% is 0.08. Okay, so I've just copied that first bit of the log tables here, so we have it sitting for us. And I'm obviously going to use the depreciation formula here because it's a new car, and as you know, a car loses value from the minute you buy it. So its value is what's called depreciated or reduced down. Okay, and they want to know if it loses value at a rate of 15% every year. So every year it loses 15% of its value. What will it be after 4 years? Okay, so the interest rate then is 15%, or as a decimal, you could divide 15 by 100, and that will give you 0.15. Okay, so then F is equal to P times 1 plus I to the power of T. The reason I write down the formula like this is to tell the examiner, whoever's going to correct your Leaving Cert, that you know what you're talking about. Okay, so make sure you put down the formula just in case you make a mistake, because we're all humans, in the next part. So the value you started with was 20,000. 1 plus I as a decimal to the power of 4. Okay, and grab your calculator. 20,000 bracket 1 plus 0.15, close your bracket to the power of 4, and I'm getting something that's not right because I used plus. My apologies. That should be a minus. I did use the wrong formula, didn't I? I use compound interest, but it's a minus. Okay. And the reason I knew I was wrong was because the value was actually greater than the 20,000 that I started with. So that's how I knew that I was wrong. So in fact, this time I got 10,440.125, and because it's money, I need to round that to 2 places of decimal, so it'll be 0.13. Okay, so that's the value of the car after 4 years. So you can see, even though it's only using 15% of its value every year, it's practically halved in value after 4 years. Okay, Mary wishes to buy a new car which costs 24,000 on the 1st of July 2014. Buy Right Car Sales offers Mary 10,500 for her old car. She can then borrow the balance for 1 year at a rate of 11.5%. how much would she repay on the 1st of July 2015? So the easiest way to do these questions is to try and put yourself in Mary's shoes. So pretend you're buying your first car. Okay, it's 24,000. You are selling a car for 10,500. So the first thing is to figure out how much more money do you need for that car. Okay, so let's do that by subtracting what's the new car costing versus how much are you getting for your old car. And I make that to be 13,500 extra that Mary needs. Okay, she has obviously been approved for a loan and the rate is 11.5%. So how much would she repay on the 1st of July 2015? So just one year of a loan. Okay, we can use this formula if you wish. Okay, so how much would she repay? Well, she is starting off with 13,500. Her interest rate is 11.5. So as a decimal, it's 0.15 to the power of 1. Okay, 13,500, 1 plus 0.115, close your bracket to the power of 1. So I'm making that 15,052.50. So 15,000. Okay, so that's one way of doing it. It doesn't really make sense though, because that's compound interest. It's like you're putting money into a bank and you're getting interest. So the most logical way of doing it would be to take the 13,500, divide it by 100 and multiply it by 11.5%. So what am I doing there? I'm getting 11.5% of 13,500, okay? And I make that 155250, okay? And I'm going to add that on to 13,500. And I get 1505,250 as well. Okay, so the bit in black is what makes more logical sense to me. I'm borrowing an amount, I have to pay this interest rate, so I calculated the interest here. I added it on to what I borrowed. And then I get the total to be repaid. Okay, so that's the bit that makes sense to me. But what I want to show you is that that does work as well. That's all that formula is. It just does the calculation of the interest and adding it on all in one go. So that's the adding it on effectively. That's the calculating the interest bit. And it will work that way too. Okay, so either way, she's paying back 15,052 euros and 50 cents if she goes with buy right car sales. Okay, part 2 then. Bargain Deals Car Sales offers Mary 10,000 for her old car. So he's offering her a little bit less. She was getting 10,500 there. And an interest-free loan for the balance for 6 months. So she doesn't have to pay anything for 6 months. Then at the end of the 6 months, Mary would make a payment of 4,000. So that's good. During the 6 months, she's saving her money. She saves up 4,000 and she pays it off. And then on the rest, she would be charged at a compound rate of 1.5% per month for the next 6 months. How much would she repay on the 1st of July 2015? Okay, so let's work this out bit by bit. So the car is still 24,000. She's getting 10,000 for her own car. So this time she needs a loan for 14,000, or that's how much is left to be paid, okay? So that's how much she is borrowing. So she pays nothing for a while, and then at the end of 6 months, she pays off 4,000. Okay, so take the 14,000, pay off the 4,000, and now you're left with 10,000 outstanding. Okay. Now she's going to get a loan for the rest of it at a rate of 1.5% per month for the next 6 months. Now I want you to draw your attention to something, okay? So this chat up here says that the interest rate is time in years and I is the annual, and annual being yearly rate of interest, okay? So does that mean you cannot use that formula for a question like this, even though it's compound interest? Well, no is the answer. You can still use the formula. This can be in months, so your time can be in months, as long as your interest rate is also in months. Okay, so the time base has to match whatever your interest rate is. Okay, so if we go to this question, can you see that the interest rate is per month? And therefore our time is for 6 months. So I can say that T is equal to 6 and my interest rate is equal to, so 1.5 divided by 100 on your calculator, 0.015, okay? So that's my interest rate. So as long as the time base, which is months, matches the base of the interest rate, which is also months, you can use that compound interest formula. Okay, which says that f was equal to p times 1 plus I to the power of t. Okay, which is equal to, how much have we outstanding? 10,000 times 1 plus my interest rate 0.015 to the power of 6. Okay, let's put that into and I am getting 10,934. I'm getting 0.43264, so 43. Okay, so that's how much she has to pay on the 1st of July, 10,900. Okay, so you can see we use that formula again. Could I do it this way? Yes, but this is what you would have to do. Okay, so you would take your 10,000. So I'm just going to write it down here because I'm going to rub it out in a minute. So month 1, I would take the 10,000, divide it by 100 and multiply it by 1.5. Okay. Just going to work it out for a little bit, and it's 150 euros. Add that on to the 10,000 and I get 10,150. Okay, so that's how much she would have to pay back after month 1, month 2 of the interest. You start off with 10,150 divided by 100, multiply by 150. And I think we did one of these in a previous video where we did the long way of doing it. And you get 152.25, add it on to the 10,000 and you get 10,152.25, and then 1, 3, 4, 5, 6. Okay, so you can see now this is why this time this is the easier way to do it, even though this way logically makes more sense, but mathematically that's an easier way to do it. Okay, but nothing's stopping you working it out the long way if you wish. Okay, either way, by the time you get to the end of the 6 months, you're going to have 10,934. Okay, part 3 then. Which of the above options should Mary choose if she wishes to pay the least amount? Well, buy right car sales, so buy right. So again, if you put yourselves in these shoes, you're going to take the deal that is the cheapest, aren't you? Is 15,052.50. Bargain deals. 10,934.43. Okay, when I look at these amounts now, and it's a loan, okay, so all of these companies are competing with each other. So that difference doesn't feel right. So either I've made a mistake or I'm forgetting something, okay? So what you have to remember is that in bargain deals, yes, that's how much you paid at the end of, or on the 1st of July, but you'd already paid off 4,000, okay? So you'd have to add on that 4,000 that you already paid off, so that you'd get 14,934.43. Okay, so the difference then is a lot less, and that feels more right. So 15,052 times 50 minus 14,934.43. What is that? 118.07 euros. So which of the above options should she choose? She should choose bargain deals because it is 118.07 cheaper. Okay, and that concludes that question.
If you are interested in technology or engineering, but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in Electronics and Self-Driving Technologies, and from there to the Masters.
Check out the link below for more information.